Today, we're diving into something that literally acts as our solar system's cosmic shield, the heliosphere. The protective bubble is created by our sun, and for the first time, NASA's new IMAP mission is set to map its boundaries with unprecedented detail. This is an exciting topic because the data IMAP sends back won't just rewrite physics textbooks, it will instantly improve space weather warnings that keep our modern technology safe. The heliosphere is a giant bubble of solar wind that protects Earth from dangerous galactic cosmic radiations. And NASA's new IMAP spacecraft is now sitting 1 million miles away at a perfect vantage point to measure this shield and provide real-time 30-minute advance warnings of incoming solar storms. This mission is essential for protecting the future of astronauts, satellites, and the power grids here on Earth. What do you think about this, John?
I think this is cool. So we're not just talking about our planet. We're talking about the solar system here. So just to kind of break it out. So the heliosphere consists of distinct regions. So the innermost layer, that's where all major planets reside, and solar winds travel unimpeded at full speed for billions of miles until reaching the termination shock. Then that's followed by the heliosheath, where solar wind slows and deflects under pressure from the interstellar medium. And then there's finally the heliopause, which is the sharp boundary where solar and interstellar magnetic fields push against each other in equilibrium. So the termination shock occurs where solar winds flow from supersonic to subsonic speeds as it incurs interstellar material, while the heliosheath is the turbulent, compressed region between the shock and the outer boundary. Now, the heliopause represents the theoretical boundary where the sun's solar wind strength is no longer great enough to push back stellar winds from surrounding stars. And that creates a balance between solar wind and interstellar medium pressures. So beyond the heliopause, there's a 40-fold increase in plasma density, radical reduction in solar particles, and cosmic rays increase dramatically. So it's a protective sphere that protects us from a lot of harmful cosmic radiation, if that makes sense. I think this is cool. What are your thoughts on this?
I think it's cool too, but let me maybe put this in a different perspective so people can understand it.
Yeah.
Because you really get scientific. The heliosphere is a gigantic, no, but that's why we're here. The heliosphere is a gigantic magnetic bubble that the sun blows around our entire solar system. Think of it like a magnetic field around a ship that pushes away water. The sun constantly shoots out stream of charged particles called solar wind, and this wind inflates the bubble. Its main job is to act as a force field, deflecting the super fast, dangerous radiation called galactic cosmic rays that come from the rest of the galaxy, keeping us and our planet safe. The IMAP mission is like sending a new, highly advanced radar dish to the edge of the bubble to finally get a clear picture of what's going on out there.
Yeah. So it's tough to kind of grasp, but so here's the thing, and just to kind of talk about IMAP for a second. IMAP is going to provide approximately 30 minutes advance warning for harmful solar radiation. And that's crucial because NASA is preparing for the Artemis 2 mission around the moon in early 2026, and also future potential human flight missions to Mars. So the mission is going to study space weather conditions that can disrupt global communications, electrical grids, damage satellites, pose health risks to astronauts, a whole bunch of things. For those of you that don't know, so if you ever look up in the sky at night, if you're ever lucky to see the northern lights or aurora borealis, that is cosmic radiation. Those are solar rays. That is magnetic disturbance flowing through our protective layers. Sometimes, there's solar flares that come from the sun that are so strong that disrupt communication, and they can even get as high at some point to kind of wipe out all electronics on Earth. So that's why this stuff is critical.
Absolutely. Like, this is going to rewrite textbooks on the heliospheric physics, fundamentally changing our understanding on how our solar system interacts with a wider galaxy. It's a new detailed map of previously blurry boundaries. So, By predicting solar storms, it helped protect satellites that power your GPS navigation, cell phone signals, and broadcast televisions. So we'll have more reliable GPS and communications. The data will help forecasting centers issue alerts that allow power companies to protect the electrical grids from surges caused by intense solar storms, preventing major blackouts. Safer air travel, enhanced forecasts will benefit airlines. A strong solar weather can affect communication navigational systems, leading to smoother, safer operations. And future space exploration. IMAP is directly providing critical safety data for NASA's Artemis program and eventual crewed missions to Mars, protecting the future of astronauts and humanity. So the mission is already launched and is operational. It took 108 days to reach its position at the Lagrange point 1. The primary data collection phase is planned for 2 years. Real-time data broadcasting is now active via the iAlert system, meaning we are already seeing benefits in enhanced space and weather forecasting models.
Yeah, this is really cool. I'm really excited to see what can come of this, right?
Yeah, and hopefully, this, like, as we map more and more stuff, we'll figure out more about what the universe is going on, but maybe we'll also get to know and understand a little bit more of what's outside the universe. Like, what's that satellite or asteroid everyone's talking about that might be alien because it just changed its trajectory?
Yeah, I can't remember what the name of it was, but yeah, I know what you're talking about.
Anyway, I saw Elon Musk talking about it the other day, and he doesn't believe that it's alien ship, and the asteroid's mostly made of nickel. It would take a lot to move it off course. Anyway, that's besides the point. This is an incredible technology that we're going to keep track of. Things in space, more and more missions in space. I feel like we are living in a sci-fi world, and that is a cosmic shield that is absolutely essential for life, modern society. The fact that we now have a new highly advanced sentinel sitting 1 million miles away, constantly watching our flank, is a truly significant step forward for humanity. Like, who would have thought we'd have spaceships out there watching for our things coming in, now? So what do you think? Are you ready for textbooks to be rewritten? Let us know what you comments below. Are you excited about this? So what do you got going on, John?
Yeah, well, just helping companies secure government funding. So, it's a great time to reach out if you have any questions. How about you, Craig?
Well, there's a lot going on over at flowgrammer.ca. We're doing automation and AI and business processes. We do events, but we're really ramping our business up. And check out all the things we're doing over there. If you're interested in business automation, we've got community events where we're teaching everyone. We do an online, and we're about to launch our new resource center, flowgrammers.ca, which might be out when some of these are out. Other than that, check out for everything we do. Our monthly startup investor drinks, where you get to pitch to the crowd, business owners and investors, and have real conversations and make real connections. So for all those things, check out TorontoStarts.com. And for everything else, anything else, John, before we say goodbye?
No, just reach out to me on LinkedIn, John Irwin, if you want.
John Irwin on LinkedIn. Thanks, everyone. We'll talk to you soon.